Hello my students, hello everyone. Here we go for another new lesson in light. Today we're gonna discuss the concept of the total internal reflection and the critical angle. What about this phenomena which is naturally occurring when you see light passing through this glass optic and gets totally internally reflected, like this shape, like optical fibers. If you have heard about this terminology, we'll study it. And light never passes through the other medium. Why this phenomena is going to happen and why this phenomena takes place? This is due to something we call the critical angle. The angle of incidence, which is phi, takes place when light passes from glass into another medium like air, as shown, refraction. We call the refraction takes place when the phi is smaller than the critical angle. But in this case, here's phi. When the phi equals the critical angle, refraction takes place with angle 90 degree. This we call a grazing light. But if light came with this angle, phi, and in such a situation phi is greater than the critical angle, no refraction takes place while a total internal reflection takes place like this. The critical angle is a fixed value defined for every medium. Every medium has its own critical angle. If the light falls by an angle less than this angle, refraction will take place. And if light falls with an angle greater than that angle, total internal reflection will take place and no refraction happens. Only when the light falls with the angle equivalent to the critical one, the refraction takes place by 90 as shown. N12 equals sine phi over sine theta, N2 over N1. Sine phi 1 and sine theta 2 in the first medium and in the second medium, of course. Therefore, the angle is inversely proportional to the refractive index. Thus, we can remember that the refractive index of the air, N air, equals 1, which is the smallest absolute refractive index, as mentioned before. Therefore, the angle in the air is the greatest one. As shown, when the angle is 0, the light passes normal to the surface, making angle 0. And when the angle of reflection increases, so, and then in such a way, and then in more refracting, till it reaches a certain value, it no longer takes a refraction path while passing from the second medium to the first medium or vice versa. The light passes from a medium to another medium undergoing a reflection process, and this takes place from a medium of higher refractive index to a medium of lower refractive index. In other words, the light passes from a medium of low velocity to a medium of high velocity. This is because the velocity is inversely proportional, as we had mentioned before, with the refractive index. Let's go for the definition of the critical angle. It is the angle of incidence. That corresponds to angle of refraction equal to 90 degree. But keep this in mind and never forget this note: the angle of incidence in the denser medium, while the angle of refraction in the less dense medium. What do we mean by the word denser medium? Value of refractive index of a high number. And what do we mean by less refractive medium or less dense medium? A medium having n less than 1. One of the other medium, of course. For example, glass and water. Glass has a refractive index of about 1.3 and Water is having refractive index of 1.2, something like that. Therefore, the glass of 1.3 is denser than the water. Or oil and air. Oil about 1.4 and air is 1. The angle of refraction to be compared with 90 and the angle of incidence to be compared with the critical angle can be concluded when light passes from the oil to the air, not vice versa. And applying Snell's law, n1 sine phi equal n2 sine theta, then n glass sine phi critical equal n air sine 90, comparing the glass with the air. N air equals 1 and sine 90 equals 1, therefore n glass sine phi critical equals 1. We can conclude that n glass is 1 over sine phi critical. Of course, any other medium. And water equal 1 over sine phi critical, and so on. For example, n glass equals 1.5. Calculate the critical angle. 1.5 equals 1 over sine phi critical. Sine phi critical equals 1.5. Using the cross multiplication issue here, using the calculator to get the inverse of the sine, shift sine 1 over 1.5, we get phi critical equals 41.8. That was all for the critical angle. Hoping you to stay safe and goodbye.